Hello, I'm Paul Beckwith. 5 years ago, I did a video with the title, Can Global Sea Level Rise 7 Meters by 2070? Then I revisited that question a couple of years ago with another video, with a very similar title. And basically, my questions at that time were related to by looking at the doubling rates of the ice melt on Greenland and Antarctica, which will be huge sources of water, as the melting of these glaciers on land accelerates and all that water drains into the ocean and raises sea level. So I'm revisiting that question, can global sea levels rise 7 meters by 2070? Okay, in the Paleo records in the past, we've had these meltwater pulses, which have been very rapid, giving the equivalent of about 5 meters of sea level rise over the space of about 100 years or so. So that's 500 centimeters, 5 meters, 500 centimeters over 100 years. That's about 5 centimeters per year, which is, is this sort of number possible? So I'm going to look at a recent paper that's called Persistent Acceleration in Global Sea Level Rise since the 1960s, to look at where we are now and to revisit that question, my views on can it rise 7 meters by 2070. And to cut to the chase, I think the answer to that question is yes. I don't see how, just to give you an example, that heat wave 2.0, basically, the second heat wave this summer, massive heat wave that went up from the Sahara. So this heat dome went from the Sahara Desert north over into Europe. What are you doing, Mr. Shackleton? He's exploring, like his namesake, Shackleton the Explorer. So the heat wave that formed in the Sahara Desert basically went over Europe, caused a heat wave over Europe, and then that crest of the jet stream, that wave of the jet stream, very persistent, slow wave, then went northward and sat over Greenland at the end of July, beginning of August. And there were melt rates of up to like 12 and a half gigatons of ice in a single day. I think in the month of July, the melt loss was about 217 gigatons of ice lost just in 1 month. And I'll put that in context. Some up until recently, that would be a whole year of Greenland melt. So the melt rates are greatly accelerating from Greenland. Antarctica is not looking that healthy at all. A while ago I talked about a paper saying that the permafrost thaw rates in the Arctic were 70 years ahead of schedule. What we expected in 2100, we're now, we're seeing basically, or 2090, what we're expecting in 2090, we're seeing now, 70 years ahead of schedule. So I basically coined the phrase 2030 is the new 2100. In terms of Greenland ice melt, we're seeing, what we're expecting in 2050, 2060, 2070 in terms of melting is happening now. And in terms of sea level rise, what the rate of acceleration of sea level that we've seen an uptick since we started using satellites, altimeters to measure sea level, and that started in 1993, and we've seen an acceleration since then. But that acceleration actually started 30 years earlier in the 2060s, as I'll show you in this paper. So basically, as far as climate change goes, everything is happening much faster than expected. And when we say that term, whose expectations? The expectations of mainstream science, the expectations of the general public, not the expectations of myself, not the expectations of people that have followed me for many, many years. And like I said, this video was from 5 years ago. Can sea level rise 7 meters by 2070. And again, I emphatically say yes, it's very possible. Okay, so let's stop playing with the cat. He's in a good mood today. And let's get right into these papers and stuff. So this is the paper. But before I talk about this, this is my website, paulbeckwith.net. So I've done a lot of videos about the Arctic sea ice loss, about what that will entail for humanity in terms of the albedo, the darkening of the Arctic, the excess heat that will be put into the climate system. And again, when the sea ice melts, it doesn't directly raise sea level, but it makes the warming around Greenland, it basically, Greenland sticks out like a frozen thumb, like a sore thumb. When there's no sea ice in the Arctic at all, Greenland will be the last bastion of ice there, and that ice is rapidly going. We're seeing it rapidly going. There's these very crazy surface melt events, even at the peak of at the summit of Greenland, 3,300 meters above sea level, when it should be cold there, basically never go above zero. And for the third time in about 800 years, there's been huge melting on the surface all the way up to the summit. The latest event, just a few weeks ago just a week or so ago, end of July, early August. So don't forget to check out my website, paulbeckwith.net, and please consider donating to support my videos and my research. I really do rely on my donors, and I want to thank everybody that's made donations to me to keep my work at joining the dots of abrupt climate system change going. So on my Twitter feed at Paul H. Beckwith, of course, this was the last post on some of my videos about albedo. I do post, it's not just climate stuff, there's lots of interesting stuff. So here's a bubble vortex, and a jellyfish. So, really, really interesting stuff. I'm a scuba diver. I love to snorkel, and it's one of my passions. So methane. So this is first a little bit of mishmash stuff from my Twitter feed. Methane. This is the globally average methane. Okay, the variation from month to month, and then the yearly average. And we just had a rise. A rise was reported for a few months ago, April. This should be 2019, I believe, April 2019. Rise of 9.1 ppb. The sea ice in the Arctic. Everybody's following the sea ice. Clearly, there's very, very little thick sea ice left. Here's some of the thicknesses as of August 6th. So less than a meter, around the edges here. The thickest stuff is 1.2 meters, 1.6 meters, 2 meters. Like there's some thicker stuff here, but very, very, not a lot. Okay, we've lost the multi-year sea ice. These are some of the air temperatures on top of the ice on the same day, August 6th, a few days ago. And you can see the temperatures. So the ice is being hit from above with the very warm temperatures. It's being hit from below with the water temperatures. There's export out the Fram Strait. There's export through the Canadian archipelago. This is fairly new, a new mechanism for ice loss, because the ice used to get ridged up here, and that would create dams and stop the ice from going through, trickling through the Canadian archipelago. No longer happens. There's warm water coming in the Atlantic side, warm water coming in the Bering Strait. I mean, the ice is being hit from every direction. Of course, there has been a lot of stuff. Global climate sensitivity is going to be reported to be high. People are working on Assessment Report 6 to come out in 2021, the Intergovernmental Panel on Climate Change. You can see the dates, AR1 1990, the last one was in 2013, and the climate sensitivity We're talking about, this is sort of the nominal range here. Doubling of CO2 would cause between 1.5 and 4.5 degrees Celsius, and that number is coming up. The expected value is coming up. Okay, the climate is a lot more sensitive. So there's lots of stuff here. The spiral, loss of ice volume, setting record lows, Greenland melt, setting record lows. And look at the temperature. This is the temperature this is the July surface temperature estimates. And there's huge warming and huge anomalies in Antarctica. Look at all this warming that's going on in Antarctica now. Extremely concerning. Okay, and this is one of the articles on the global sea level acceleration starting in the 1960s that I'm going to focus on. You can see the westerlies here, and an acceleration of sea level rise here, and a slowing down of sea level rise in this location. So I'll talk about the details of it. The overall ocean is warming. This is July sea surface temperature anomalies. It's a record of 100 years, and you can see that there's fluctuation from, there's cool areas and warm areas, cool areas and warm areas. As we get into the 2000s, the warm areas, the red anomalies take off, and huge anomalies up here in towards the Arctic. And this is the, tweeted out about the global sea level rise is continuing to accelerate, which is no surprise since the melt rate from Greenland and Antarctica continues at ever faster rates. We're also getting many more marine heat waves, which expand the ocean water, overfilling the ocean basins. Okay, so let me get into the articles. So this is a Carbon Brief article. Global sea level rise began accelerating 30 years earlier than previously thought. So basically began to accelerate in the 60s, and we know it accelerated, it was reported to have accelerated in the 90s with the better data from satellites, but this analysis looks at the gauges on coastlines, mostly in the northern hemisphere, and takes the data from sea level rise there and combines it with the data from the satellites, and uses different statistical methods to get, a better handling of long-term trends and also of shorter-term variations, which is the key, which is a novel thing that was done in this paper. And it found that the southern hemisphere, home to many of the developing small island nations, has experienced the majority of the observed sea level rise. Okay, so the ocean heat uptake will likely increase again in the near future, further increasing the rate of current sea level rise. So the acceleration is not staying constant. If the acceleration is rising, then the rate, remember that you have a, if you're going a certain distance and you take the derivative of that with respect to time, or the rate of change of distance with time is speed or velocity, and the rate of change of velocity with time is acceleration. And we can talk about the rate of change of sea level rise, right? We can talk about the absolute sea level rise, distance, length. We can talk about the rate of change of that length, which is the velocity of sea level rise, and we can also talk about the acceleration of sea level rise, which is the derivative with respect to time of the velocity. Okay, so global sea levels rose by about 20 centimeters over the 20th century. So 1 inch is 2.54 centimeters. So 8 inches times 2.5 is 20. So this is 8 inches. It was primarily due to melting ice from glaciers on land, some from Greenland and Antarctica, but mostly glaciers, mountain glaciers, and ocean warming. Ocean warming was the biggest factor, which causes the thermal expansion of water. Okay, and the thermal expansion of water then overfills the basins and causes the sea level rise. And of course, rising sea levels are a huge threat to coastal regions. putting people at risk, huge economic risk, and people will have to migrate and move, and so on. So I'll continue this video. Thanks for listening.